Article 250.52a requires that all metallic piping systems and equipment bonded to them shall be connected to the grounding electrode system. This requirement applies regardless of the length of the copper water line outside the building. The primary purpose of bonding metallic piping is to establish a low-impedance path for electrical current in the event of a fault. This low-impedance path facilitates the quick operation of overcurrent protective devices, such as circuit breakers or fuses, thereby minimizing the duration of a fault and reducing the risk of electrical shock and equipment damage. The pressure-reducing valve, being a metallic fitting connected to the copper water line, falls under this bonding requirement. The presence or absence of a gasket in the union nut of the pressure-reducing valve is irrelevant to the bonding requirement. Gaskets are primarily intended to prevent water leaks and do not provide sufficient electrical insulation to negate the need for bonding. The bonding connection must be made using approved methods and materials, ensuring a reliable and permanent electrical connection. This typically involves using bonding jumpers of appropriate size, selected based on the size of the service entrance conductors, and listed connectors suitable for the materials being joined. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding, including conductor sizing, installation methods, and permissible materials. Compliance with these requirements is essential to ensure the safety and proper functioning of electrical systems. The grounding electrode system serves as the reference point for electrical potential within the building. It typically consists of one or more grounding electrodes, such as ground rods, ground plates, or the metallic water pipe itself, connected to the service equipment enclosure and other grounded components. The connection between the metallic piping and the grounding electrode system must be electrically continuous and mechanically secure. This means that the bonding connection must be able to withstand mechanical stresses and environmental conditions without compromising its electrical conductivity. Inspections and testing are essential to verify the effectiveness of the bonding and grounding system. Continuity tests can be performed to ensure that the bonding connections are intact and that there is a low impedance path to ground. Ground impedance measurements can also be taken to assess the overall effectiveness of the grounding system. Any deficiencies identified during inspections or testing must be promptly corrected to maintain the safety and integrity of the electrical system. The requirements for bonding metallic water piping extend beyond the immediate vicinity of the building entrance. Any metallic water piping system that is likely to become energized must be bonded to the grounding electrode system. This includes piping that is exposed to electrical equipment or that runs through areas where electrical faults are likely to occur. The size of the bonding jumper used to connect the metallic piping to the grounding electrode system must be determined based on the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the bonding jumper for various service entrance conductor sizes. It is important to consult these tables to ensure that the bonding jumper is adequately sized to carry the expected fault current. The bonding jumper must be installed in a manner that minimizes its length and avoids sharp bends or kinks. This is to reduce the impedance of the bonding path and ensure that the fault current can flow freely to ground. The bonding jumper must also be protected from physical damage and corrosion. This can be achieved by using appropriate conduit or other protective measures. In addition to bonding the metallic water piping, it is also important to bond any other metallic piping systems that enter the building, such as gas piping or steam piping. These piping systems can also become energized in the event of a fault, and bonding them to the grounding electrode system helps to prevent electrical shock hazards. The requirements for bonding these other metallic piping systems are similar to those for bonding metallic water piping. The bonding jumper must be sized appropriately, installed in a manner that minimizes its length and impedance, and protected from physical damage and corrosion. It is important to note that the bonding requirements may vary depending on the specific application and the local electrical codes. It is always best to consult with a qualified electrician or electrical inspector to ensure that the bonding is done correctly and in accordance with all applicable requirements. In summary, Article 250.52a of the National Electrical Code mandates the bonding of all metallic piping systems and equipment to the grounding electrode system. This requirement applies to pressure-reducing valves within 5 feet of a building entrance, regardless of the length of the copper water line outside the building. The purpose of bonding is to provide a low impedance path for fault currents, preventing electrical shock and equipment damage. The absence of a gasket in the pressure-reducing valves union nut does not negate the bonding requirement. Proper bonding practices, including the use of appropriately sized bonding jumpers and listed connectors, are essential to ensure electrical safety and compliance with the NEC. Regular inspections and testing are crucial to verify the effectiveness of the bonding and grounding system.